today's presentation, I would like to explain you one more important example on this superposition theorem. Let us solve a simple example on this principle. In today's presentation, I would like to explain you another simple example, and in fact it is very important model on superposition theorem, right? Let us consider this simple example which has some resistors and two sources. One is current source and another is the voltage source, right? So our question is to find out the voltage across 2 ohm resistor V0 by using the superposition theorem for this simple circuit. Find out the V0 by using the superposition theorem, right? So we know that what is the superposition theorem states that the voltage across 2 ohm resistor is the algebraic sum of the voltage which was obtained due to the individual sources acting alone. That is the definition of a superposition theorem. That means that at a time we should consider only one source, either current source or voltage source, whatever it is. At a time we should consider one source only, and the rest of the source we must make it or keep it off, or we should make it turned off, right? So if you see the output voltage V0, this is the expression which I can give for this, right? So the V0 can be expressed as V0 is equal to V0 with respect to 12 volt voltage source as well as plus V. So I can write again V0, that is output voltage with respect to 5 ampere current source. So means that what individually we should consider, by considering the 12 volt voltage source with respect to this voltage source, I have to find out V0 where the 5 ampere current source must be switched off. That is the first condition. And the second condition, by considering the 5 ampere current source, I have to find out V0 where the 12 volts voltage source must be switched off. That is the meaning of it, right? So now let us consider first the V0 value with respect to 12 volt where the 5 ampere is switched off. So how the current source will be switched off? Simply by removing it. You can open circuit it. It means that simply you make it open, that's it. So the current source must be open circuited. As I already explained in the last presentation, the current source, wherever the current source is there in the circuit, that must be open circuited. So if you make it open circuited, then the circuit becomes like this. Very simple, right? So this is the simplified circuit. So means that what actually, so if you remove this current source, 5 ampere current source, the equivalent circuit will be like this. Then your 5 ohm and 3 ohm, these two becomes in series, and this is the 2 ohm is the another resistor which is also in series with this, but we have to find out the voltage across this. Now, so what is the V0? V0 can be, so I can write here only your V0 with respect to 12 volt gives us V0 is equal to input voltage 12 into 5 plus 3 8, it is series resistance by, I mean it is the voltage across 2 ohm resistor, sorry, it is 2 ohm by total resistor 5 plus 3 plus 2. So 5 3 8 plus 2, 8 plus 2 10. Clear? So the voltage, so the V0 we are going to find out across 2 ohm. Therefore the resistor across which we are going to find out that resistor by the total resistance 5 plus 3 plus 2, 5 plus 3 8, 8 plus 2 10. So it is 2 ones are, 2 fives are, 5 ones are, 5 2 and 4. So your V0 with respect to 12 volt is equal to 2.4 volts, right? This is with respect to 12 volt voltage source. That is what your V0. Now we have to find out with respect to the current source. Now again I am connecting my 5 ampere current source here, right? With respect to this current source, I have to find out this V naught with respect to 5 ampere current source, where my voltage source must be. I am removing this. So remember that value is, it is 2.4, right? Now the second step is I have to find out the same V naught with respect to 5 ampere, where the voltage source must be turned off. How the voltage source must be turned off? Simply the voltage source must be short circuited. The voltage source must be short circuited. Likewise, so how this can be? So this is very simple actually. So in this case we have to apply the mesh analysis, where you can take the current as, maybe you can rate. So this is the current direction which we supposed to consider, and again this is the one mesh, this is the another mesh. Let us consider here, this is the I1 current in the first mesh, and this is the second mesh where I am considering as I2, and the flow of the current is definitely in this direction. Right? Therefore, if you apply, so at this particular point, if you apply the your KCL, by using your KCL, definitely at this particular point, how you can write actually, 5 ampere is entering here, your I2 is also entering here, and your I1 is leaving here. Therefore, what I can write actually, so this is my I1 is equal to, how I can write actually, okay, so my I1, this is I1 actually, therefore it is going out from the node. So my I1 is equal to 5 ampere plus I2, or I2 plus 5. Shall I write like this? So my I1 is equal to I2 plus 5 at this particular point. Therefore this is the one relation which I can get actually. This is my second equation, you can call it as. And similarly, if you apply, because the 5 ampere current source is the common between two meshes, okay, where I can apply the super mesh concept. So in the super mesh concept, the 5 ampere current source must be removed. So by using the super mesh concept actually, this 5 ampere current source must be removed. Therefore assume that there is no 5 ampere current source where I am applying the super mesh. According to the super mesh, how I can write actually? So 2 plus 3, so these two are comes under first mesh, therefore 2 plus 3, 5 into I1. So according to super mesh, it is 5I1 plus 5 into I2, right? 5 into I2 is equal to 0. This is my another equation, third equation. And by simplifying this, how you can write 5 plus 5 common, therefore can I write from this I1 is equal to minus I2? I can bring the equation I1 is equal to minus I2, right, from this. Therefore I am erasing this particular circuit. Therefore, by using these two expressions, what I can write actually? So, by using these two equations, right? So, it is I1 is equal to minus I2. Therefore, substitute I1 is equal to minus I2 here. Therefore, if you substitute equation, you can call it as equation number 4. Substitute 4 into 2 actually. So, substitute equation 4 in equation 2, you can write, substitute equation 4 into equation 2, then you will get I1 is equal to minus I2. Therefore this implies minus I2 is equal to I2 plus 5. This implies, okay, bring this I2 this side, then definitely, or otherwise you can take this I2 right side and 5 you can write like this, whatever the way you can write. So if you write that, you can bring this 5 to left side, then minus I2 to the right side, it is I2, then if you bring this I2 to the right side, plus 2, so total it is 2I2, right? And from this, what is your I2? I2 is equal to how much? It is minus 5 by 2, it is definitely minus 2.5 amperes. Clear? This is your I2 value. So if I2 is equal to minus 2.5, then what is your I1 value? I1 is equal to minus I2. So from here, definitely your I1 is equal to minus of minus 2.5. How much? So minus into minus plus. Therefore your I1 is equal to how much? 2.5 amperes. Therefore your I1 is equal to how much? Your I1 is equal to 2.5 amperes. So this is what the current actually flowing through the first mesh. Okay, that is the I1. Now what we supposed to find out? The voltage across 2 ohm resistor. Therefore voltage across 2 ohm resistor with respect to 5 ampere current source is nothing but 2 into I1. Clear? So 2 ohm resistor, and the current flowing through that mesh, it is I1, it is 2.5. Therefore, it is 2 into 2.5. How much it is? 5 amperes. Clear? Sorry, 5 volts. It is 5 volts. So this is what your V naught with respect to 5 ampere. Now what is your total answer? Now tell me. So total my V naught is equal to, what is my V naught? What is my output voltage? V naught is equal to, it is V naught with respect to 12 volt and V naught with respect to 5 ampere current source. What is V naught with respect to 12 volts we have seen? It is 2.4 volts. And what is V naught with 5 ampere current source? It is 5 volt. 5 plus 2.4, it is 7.4 volts. This is your final answer. This is what your final answer. This is how we have to solve the simple given examples based on the superposition principle, right? I hope you understood well this example, and some more few examples we can see in our subsequent presentations. Thank you very much.